Hello and welcome to another exciting Breakfast with Unity. So, happy Thanksgiving to everyone who's celebrating Thanksgiving today. I know I am, so there are maybe other people as well. And we're just going to be doing this morning show. We're not doing the evening show because of Thanksgiving. So, what we're doing today is we're on the screen, right? Yeah, we're on the screen. So we worked on a grenade launcher yesterday, and today we're going to add a targeting indicator for us that I think is going to be really fun. We'll find out how things actually go. This may be a two-parter. I'm not 100% sure I can get everything done in today's episode, and it will depend on how much time we have, how exotic we'll get with this. So what we're going to call this is we're going to call this ballistic targeting. And I grabbed this off of the grenade launcher episode we did yesterday. So this should be an identical episode, identical level for right now. So I'm just going to go ahead and get rid of most of the ragdolls. I'm just going to leave one here. So delete all these. And we're just going to make sure that he still works the way that we kind of expect. Yay, cool. So obviously, when we're trying to hit something at that close range, it's pretty trivial. But especially at the speed that we're shooting our projectile at. But if we wanted to hit something, we have an actual gravitational pull on our projectile. If you launch this thing, you'll see that it drops over time. So it's possible to, using equations of motion, solve for how high an angle we have to do to actually fire this to hit. So if you notice here, our distance is entirely dictated by our angle. So if we shoot down low, the distance is low, and when we shoot higher, we get higher distance, and till we finally go off the map on these. Or maybe I'm still hitting at the end, and then it goes back up again once we start coming back down. So I'm going to change something already. First person controller by default doesn't allow us to look straight up. I want to be able to look straight up. So negative 90 and 90. So now we should be able to actually fire a projectile straight up and hit ourselves. So this should eventually come back down. There we go. So the first thing we're going to do is actually do the equation, and because this might take the most time. And so first off, I'm going to just search the internet for ballistic equations. And the very first thing that comes up is trajectory of a projectile in Wikipedia, and it is quite detailed, and it's wonderful. So they give you a lot, they give you the generic formulas and stuff that you can solve for yourself, and they also solve for them for you. So like, there's the distance equation here, which we don't care. So the information we have is we have the distance to the target, or at least we can have that. That's just simple math to figure that out. And we have the speed that our projectile's going, and we have our height to the target. That's something else we can figure out. And so the equation that we actually want is angle theta required to hit coordinate xy. And what this does is, if there's a height differential, this y represents the height of the shooter compared to the target. And this height can be negative. Like, you could possibly have it be negative, and this equation will still work. And so the variables we need are the velocity, so we know that, because we're going to be shooting the projectile at set velocity. The velocity, again, we know that. G is the gravitational constant, we know that. That's whatever our gravity is set to in project settings physics. So it's negative 9.81, it's a little simplified version. We need the x, which is the distance. We need the y, which is the height differential. And we need g again. So we have all the variables we actually need. So let's actually start writing these out. I'm going to create a script called create C# script ballistic targeting is what I'm going to call it. One of the few times we've had a script named after the episode. Let's start with that equation first. So I'm going to write a function for that. We're going to have it return... well, I'm not sure what it's going to return yet. I'm just going to do a void for right now. So it will return something, or we'll return it in some way. So calculate trajectory angles. All right. So calculate trajectory angles. So what variables do we have? We have v. So let's make a float v. Let's just figure this one out. So we're going to do a float x. I'm just going to name them the same that they are in the equation, even though I would call that d because it's distance. Float y, I would probably call that height. And g, float g. Those are all of our things here. So let's define these. So v is going to be equal to something we pass in. So we're going to have a public float velocity. And we'll just set it equal to something. And this v is just going to be our pass-in velocity equals velocity. Our x is going to be our distance to our target. So we're going to have a target. So public transform target. And I like to put the stuff you have to fill in above things. So we're going to have a target. So x is the distance to our target. So, and it's just the horizontal distance. We don't care about the height or anything else. So what this represents is, we're going to do a little bit of math to get it. So vector 3 target vector equals target dot position minus transform dot position. So this gives us our target vector, and then our x will be equal to okay, so x will be equal to, so we're going to do target vector, because I said we don't care about anything except for the distance to the target horizontally, so we only care about the x and the z values, we don't care about the y. So we're going to make target vector dot y equal to 0. And that'll be explicit, even though I don't think it matters in this case. So target vector dot y equals 0, and so float x is equal to target vector dot magnitude. So that's the distance we have to our target. So our height is going to be similar, except for it's only going to take the y into account. So we actually do care about the y here. So let's create a separate. Let's just store the y real quick. We're going to create float height equals target vector dot y before we set it to 0. So this might need to be negated, but we can do that easily. I'm just going to set this equal to height. But we'll just see how it works first. And g is going to be equal to our physics dot gravity dot y. We're only going to care about the case where gravity's down, because these equations really don't help us very well in full 3 space or with like gravitational bodies and stuff like that. This only affects for if we just basically assume that we're on an idealized plane, which in this case we are, or multiple heights too. I mean, we don't have to be on a specific plane, but the gravity always has to go down. So so we're going to do physics.gravity.y is our g. And I forget if they want gravity to actually be positive. I think they do. So we're going to actually use a negation there. We could also do let's do a math f.abs. That's more appropriate probably. This gives us the absolute value, so that should be a positive value. So now we have all our variables, so let's create that equation, shall we? So first thing, we have an arctan here. So math f.atan. So secret programming technique number 400. Actually, it's probably way earlier than this one, but this is a really important one. Anytime you think you need an arctangent, you actually need an arctangent 2. And what this means is arctan in computing results in a positive value always. It just gives you the angle needed, and so it goes between like 0 and 2 pi is the angle. But what we want is we want the angle to be able to go negative. So like this should be our angle going up or down, and so negative, as you can see even in this example, they have a negative degrees here. So we want atan 2 so that we can get that sign out of it. And atan 2 works a little differently than you'd expect, because it actually takes 2 values. Instead of just giving it the this this result, you need to give it the top value and the bottom value. So our top value, let's actually break this down then. So we're going to need to do this eventually. I'm just going to comment that out. So our top value is v squared, and we use v squared more than once, so we can actually pre-bake that one. So let's do, actually let's just write it out as it is for right now. So we're going to do math f dot, actually let's just do v times v, because it's going to be shorter character-wise anyway. So this is v squared. Plus or minus, so we're just going to do the plus right now. There's a reason that there's a plus minus, and we'll get to that in a bit. And then we need the square root of a bunch of other stuff. So plus the math f dot square root sqrt v times v plus, what happened here? Why does it seem so unhappy with me? Oh, we don't have a v. Yeah, we do. V times v I don't know what it's doing. Math f dot sqrt. This is what we want. So v times v plus math f dot square root of v times v again. Actually, v times v times v times v, because it's quad. Minus, and then nice little brackets here, g times gx, so g times, no, just g, times g times x, g times x squared, so times x plus g times x plus 2yv, 2 times y times v. Is it just v or v squared? It's v squared. That's what I thought. Times v. We'll just do it out that way. So that's our top level value. So this one's, well, I'm just going to call this float top equals. There we go. And then float bottom, we'll do, float bottom equals just gx, so g times x. That's super simple. And so what we're going to do is float, I'm going to call it angle 1 equals math f a tan 2, and it wants the, so this is in reverse order of what you'd expect. It wants the bottom value and then the top value, I think. We'll find out here. I could have everything messed up. So we're going to do, top, wait, no, yx, yeah. So we're going to do bottom, top. Oh, gosh, I've got these probably reversed. Hold on. So it's the y would be the second one normally. So it's the first one now. So yeah, so bottom and top. That seems right. So this should return our, so what we'll do is we'll do a return angle 1 for right now. And this is definitely going to have to be a two-parter to do all the cool stuff that I want to do. So we're going to make this actually return a float for now. This needs to return actually two values in the end, and that's because we have this plus minus thing. This just gives us the plus, and so we'll see how this goes. So, so what we're going to do is we need to display this in the game at some way. So what I'm going to do is, now this angle is in radians. We may want to convert that to degrees. Very easy to do. But what we're going to do for right now is, in update, we're going to need a, we're going to need some sort of object to rotate. So I'm going to create a public transform target indicator. So our target indicator, we're going to rotate up to rotate along the x-axis the amount of the angle for whatever we're doing. So in update, we're going to calculate trajectory angles. So we're going to do float angle 1 equals calculate trajectory angles. Boop. And then what we're going to do is we're going to take our target indicator. We're only going to be using this thing for targeting, so we're going to just use its orientation. We only care about its rotation on one axis. So what we're going to do is dot rotation equals, actually, let's do this the easy way, Euler Angles. So we're going to use Euler Angles. This means that we will have gimbal lock problems, but we won't because this only deals with one axis. So we don't have to worry about it, and the axis will only be between 90 degrees and and negative 90 degrees, because otherwise you're looking in the other direction. So Euler Angles, we're going to set this equal to new vector 3, and the x angle is going to be angle 1, because that's what we're rotating around x, and then the y and z we don't care about. So we're just going to go 0.0f and 0.0f. So now let's put this together and see if it actually works. So we've got this. Does it compile first? Looks like it's compiling. Let's get rid of this main camera. I don't know why we still have this in the scene, because we're getting that audio listener problem. So let's save that. And we're going to need our indicator. So our indicator is going to be really basic to start. I'm just going to make it a sphere. And we're going to place it inside of our first-person controller. And what we're going to do with it is we're going to, I'm going to create a new empty object. We're going to put it in here as well. Are both of these at 0, 0 right now? They're not. So sphere should be at 0, 0. Game object should be at 0, 0. I'm going to call this the target, ballistic target 1 is what I'm going to call it. And all we're going to do is we're just going to offset the sphere in the z direction by a bit. So I'm going to just set it 50. Sorry, that's the rotation. We don't care about that. We want 50. So is that viewable? That's probably too far. Let's just do 10 for right now. And so now I have this ballistic target, and what we're going to do is we're going to put our new equation on our first-person controller ballistic target in here. Our target, we're just going to hardwire right now. So I want to actually adjust our ragdoll just slightly. I'm going to make it so right now the ragdoll position is in the middle. I'm going to make it at their feet. So we're just going to move all these up so that it's about at the feet. I'm not going to be perfect on this. I don't really care that much. So that's pretty close. So I'm going to put him so he's on the ground now. We're just going to put it at 0, so he'll be standing on the ground. And then we're going to use him as the target. I'm going to go ahead and apply this. I don't think that'll break our other level too bad. Oh, it'll make them all through the ground, won't it? Oh well. We'll fix that later, maybe. Save scene, save project. So what we're going to do now is we're going to... I shouldn't have changed that one. I'll make a duplicate of it. I'll do it now. Using the power of version control, we can make this work. So we're going to use ragdoll, and I'm not going to actually change this ragdoll. So, but I'm going to do that using magic outside the show. So we have our first-person controller. We have our ragdoll here. I'm going to make sure that we actually... I'm going to delete this one, and we're going to put in our new ragdoll. And it ended up in the same position, so perfect. So we have a first-person controller. We need our target, which we're going to set as the ragdoll. And we need our target indicator, which we're going to set as the ballistic target 1. And so if we hit play now, we should... Okay, we're not seeing anything. So missing reference exception, transform has been destroyed, but you're still trying to access it. It's been destroyed. Oh, yeah. Okay, so we can't have this ragdoll destroying itself and detaching to the children. We're going to need this. So we're going to remove the component here. Oh yeah, that means it's not going to be particularly useful if the ragdoll moves. Ragdoll's a bad example. We're going to just remove this and make it work for right now. So hit play. And we have this Sphere is totally in the wrong position. I rotated around the wrong axes. Well, it changed weirdly there. Okay, I'm not quite sure what we're doing here. So if we do ballistic target 1, what does it look like? It has rotation of 0, and why would the Y be? Okay, when we start at 0, 0, right? So it's doing something. Okay, so occasionally we're getting not a number. So what that means is that we're actually getting a negative number in this set of equations here, and that means that we're getting we're actually outside of range, quote unquote. Since we're obviously not outside of range, that means I've done something wrong in the equation. As I said, there was a couple things that might need to be negated. So it might be the height, so let's try that. Negative target vector dot y. I don't think this would make a big difference, but let's hit play. There really should be no situation where we get a non-number at the distances we're talking about. So again, it's not a number. So what are we doing here? So that wasn't the problem. The problem is, let's try flipping these just in case. Top, bottom. Though I think we're getting the problem earlier. This is something we're going to have to check for eventually anyway, but we really shouldn't be seeing it. So the values that are in here are y. Let's make sure that this looks about right. Yeah, that looks about right. We have minus here. All right, cool. So if these values are bigger, so I think this is right. So bottom, top. Yeah, we're going to need way more than an episode. We're going to need more than one episode to even get the stuff done I wanted to get done. So hit play. Let's see what we're getting here. Oh, okay. It's not doing the non-number thing. Now it is. Didn't start it that way. That seems more promising, but... Oh, yeah, that's right. We need to actually set that. It might not be able to hit the target. That's right. Because we didn't set the velocity right. So we want the velocity to be matching our gun velocity. So we're using spawn on button, grenade, and a grenade is set to add force on start, velocity change. So let's go in 30 meters per second. So we need to set this to 30. Now we might get some more meaningful values. So does this not a number anymore when we get far away from it? Okay, it looks good, looks good. So the ball still seems like it's not at the right angle, but at least it's... why is it rotating when I'm rotating? Oh, that's what I'm doing wrong. I actually want this to be local Euler angles. So dot local Euler angles. Save, play. Now this might work a little bit better. Alright, so this is the indicator of where we have to aim to hit the dude. And we're at a distance right now where it doesn't seem like you need to aim. Oh, is it changing? It is getting higher. Oh, that's our problem. We forgot to convert to degrees. So we'll just do that in our calculate trajectory angle. So angle 1 times math f dot raddeg. This will make it so this in degrees. And now it should look much more right. Alright. It looks right, except for it's going the wrong direction when we go further away, which means that we have a value wrong. I'm going to try the y. And actually, technically, we want this attached to... Oh, but we don't want it to inherit the main camera's size. So we want this to be the same height as the main camera. So I want to copy this value into the ballistic target here. So let's try this again. So we move back and... Okay, so maybe it's not this that we need. Maybe we just need... So angle 1 is actually being positive. Okay, so we actually just want to negate the whole thing. So we just want to do... Wait, did I do a negative there? Is that really what I did? People must be like, what is Max? Is his brain working? So hit play. And so there we go. So now if, in theory, now I don't have a really good hit indicator, so let me create one more little sphere in front of the main camera. Create a 3D object to sphere. We're just going to put it like just 3 out. We're going to put it in the main camera. We want it 3 in the Z, 0 everywhere else, and make it much smaller, 0.1. So now we have a forward-facing indicator here. That was just a quick and dirty one. So in theory, if I shoot here, oh, and the ball doesn't have a collider, which neither of these should. Remove components. So in theory, if I fire here, it'll be about the range of our dude, which it looks like it's a little bit off. Just a smidgen. But if we do this, let's see how it does. That's pretty close. So let's try the negative target vector dot y, because there is actually a y difference in this scenario. And let's see if that makes it a little bit more accurate. So we go back here, we shoot. I'm just going to see. Let's actually see this from 2 angles. Let's look at the game here, and let's zoom in and get some angle on this action here, so we can see how close we are. So I'm going to fire this at our dude. So it's still going a little bit long, just a smidgen long, but it's close there. So the other thing I'm going to show you real quick, but we're going to call this an episode, and then we're going to do a part 2, and this was a long one, my apologies. But what we're going to do is I'm going to actually change this so that instead of doing the plus, we're going to do the minus here. And what this is going to give us is, this is going to give us the high angle to, theoretically, this is going to give us the high angle to hit the same place. So if we shoot up here, this will also come close. It'll probably be a little bit beyond him because we've got a small problem with our equation. But theoretically, it should land, yeah, landed very close to where he's at. Obviously, we still got things that aren't quite perfect. Oh, that was pretty close. We moved back a little bit. Here, let's try that again. I'm just going to go all the way back here, and we're going to shoot it at this target. And yeah, that's pretty accurate. So if we're off by a very small amount. So let's start with that, and we will explore this further in the next part. So I'm going to call this Ballistic Targeting Part 1. Thank you for watching. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Thank you very much for watching, and you guys have a great one. I will see you tomorrow with another Breakfast with the Unity at 9 a.m. PDT. Thanks for watching.